In today's notes, we are continuing with multi-step inequalities. The first example problem that is up is one that is common on standardized tests, where it gives you the solution and all of the steps completed to solve, in this case, an inequality, but a lot of times they do it with an equation as well. And they ask you to find the mistake. There's a mistake in here somewhere. We need to find it, and then we need to show what the correct solution is. So the problem that's given says 3x plus 3 is greater than negative 2x plus 5. Every time you do one of these, I try to take a look at from one step to the next, what is different. So it looks like from here, the 3x stayed, the negative 2x stayed, and it looks like they're doing something with the constants here. So if we were to go from 5 to 2, it looks like they subtracted 3 here. And that's an okay step. We subtracted 3 from both sides of the inequality. 5 minus 3 is positive 2. They brought down the negative 2x, and they brought down this 3x. At this point, it looks like they are combining this 3x minus 2x. 3x minus 2x would give us 1x. But notice they're on different sides of the inequality. So I would state, to find the mistake, I would state that in step 2, the student combined like terms. They cannot do this. Because the 3x and negative 2x are not on the same side. If they were on the same side, yes, we would combine them, and we would do 3x minus 2x gives us 1x. The problem is they're on different sides of our inequality. So in step 2, this step right here, we combine, or the student combined like terms. That's not legal because the 3x and the negative 2x are on different sides of the inequality. It also asks us to correct the mistake and solve the inequality. So let's go ahead and rewrite it as it was written. Let's do it in the same steps that they did it here. So the first thing they did was subtract 3 from both sides, and we said that was okay. So really on this first step, all we're doing is copying down step 2 there. We said that step was all right. 3x is greater than negative 2x plus 2. Instead of combining like terms, if they are on different sides of the inequality, we need to move them over so they're on the same side. And we can do that by adding 2x to both sides. I bring down my 2. I bring down my greater than sign. 3x and 2x make 5x. We do have one more step we need to complete. I have 5 times x is greater than 2. I undo multiplication with division. Divide both sides by 5. X is greater than 2 divided by 5. That doesn't come out even. I can't reduce it. There's nothing I can divide 2 and 5 by. I just leave it as 2 over 5. X is greater than 2 over 5. Our next example asks us to solve and graph. We have negative 6 times the quantity 1 plus 7k plus 7 times the quantity 1 plus 6k is less than or equal to negative 2. Hopefully we recognize we need to start by distributing. Let's distribute this negative 6. Negative 6 times 1. Negative 6 times 7k. Distribute the 7. 7 times 1. Positive 7 times positive 6k. This time the k's are on the same side of the inequality, so we can combine them. Negative 42k plus 42k. That leaves me with 0k. I don't have any k's left. We can also combine these. Negative 6 plus 7, that's 1. So I get 1 is less than or equal to negative 2. Back when we were solving equations, we occasionally had ones where all of the variables canceled out. When that was the case, if we had a statement that was true, we said that there were infinitely many solutions. And if it was false, we said there was no solution. We're doing the same thing here. 1 is not less than negative 2. This is a false statement. Therefore, when it says solve, our solution is that there are no solutions. It also asks us to graph our solution. We want our graph to show that there is no solution. So yes, we probably should number our number line, but we should not shade anything in. There are no solutions. Again, this only happens if all of the variables, in this case all of the k's, cancel out. Let's try another one where something similar happens. We have negative 2 times the quantity 5 plus 6n is less than 6 times the quantity 8 minus 2n. Again, we want to start by distributing. Negative 2 times 5, negative 2 times 6n, six times 8, 6 times negative 2n. I didn't multiply or divide both sides by a negative number, so I do not flip my inequality around. Those n's are on different sides of the inequality, so we need to move them over to the same side. I can do that by adding 12n to both sides. Negative 12n plus 12n, those cancel. Negative 12n plus 12n, those cancel also. And again, all of my variables cancel out. I just bring down my sign. I don't have any n's left. I can't solve for n if there's no n's left. This time I have a true statement. 48 is bigger than negative 10. This is true. When that's the case, we have infinitely many solutions. Any number for n makes this a true statement, therefore makes this a true statement. If I have infinitely many solutions and they ask me to graph, now I want every number to be a solution. Every number should be shaded in. So we shade in the entire number line, forever in this direction, and also forever in this direction. Everything gets shaded in. Couple review problems here. There are 3 of them. If your instructor believes you can handle it, you may work with a partner on these 3. Otherwise, they are individual practice problems. I want you to pause the video, try each of these. After most of the class has finished them, you can go ahead and play it, and we will take a look at the solutions. Number 1, I have nothing to distribute. I have no like terms, so I need to move all the m's to the same side. Subtract 4m from both sides. I get 4m minus 8 is greater than or equal to 12. Add 8. 4m is greater than or equal to 20, and divide by 4. M is greater than or equal to 5. Notice all my m's did not cancel out. You should not just fall in love with no solution or infinitely many solutions. That doesn't always happen. It actually rarely happens. Number 2, I do have a number in front of a parenthesis. Let's start by distributing. 2 times 3f is 6f. 2 times 2 is 4. We have f's on both sides of the inequality, so we need to move them over to the same side. Again, I am always going to move the smaller one. I think it's easier to do that. 4f is less than 6f, so that's the one I subtract. If you had subtracted 6f, you can still get the correct answer. 6f minus 4f is 2f. We do not flip our inequality. Subtract 4 from both sides. I get 2f is greater than 12 minus 4. And divide both sides by 2. Again, nothing I did warrants flipping the inequality. We only do that if we multiply or divide both sides by a negative number. And finally, number 3. Number 3, we do have a number in front of a parenthesis. Start by distributing. These t's are on the same side of the equal sign. If they are on the same side of the equal sign, we just combine them. 10t plus 5t is 15t. And we are down to a two-step inequality. Add 50 to both sides. Negative 80 plus 50 is negative 30, and divide both sides by 15. We get t is greater than negative 2. Relatively brief notes today. That is it for the notes. Have a good day.